Welcome. Today we've got an exciting session where we're going to discuss how I learned to code in the shower. Now I know what you're trying to think, that's Rory, that's really dangerous, but I guarantee you after today you're going to see exactly how I managed to do that and why it meant so much for me to be able to start my day easily with DevContainers and the Azure CLI. First, let me tell you a little bit about myself. I live in Johannesburg, South Africa, and I have brown hair, I'm wearing a black shirt, and I'm wearing glasses. And I am a cloud advocate for Microsoft. Cloud advocates travel and speak around the world, and they help and empower developers to use Microsoft tools and technologies to really better their lives. Today we've got an exciting session where we're going to look at mechanisms that made my life easier and hopefully can affect yours and really reduce the friction to spin up development environments. Don't forget to follow me on @RoryPetty, and let's start. So we all got mobile phones, we've got devices, and with the pandemic, I learned how to do a lot of my work with my mobile device. So I would wake up, stretch, possibly start, and they call it little screen, on the little screen, and on my mobile device. And then I would look at my day, my calendar, and say, wait a second, I'm speaking at a conference or a customer or a community, and I need an environment to show them some of the technologies. Now, normally, what I could do is I could leave that environment running for days, weeks, and months, and I would incur a heavy cost because those environments cost to actually maintain. But what I found is that it was easier for me to script my environment and then tear it down afterwards. The problem with scripting environments is that you have to do a lot of that work manually by yourself. And I needed an easier way to actually do that that was reproducible and reduced the friction of doing it repetitively. So I started actually looking at Java projects to go in to conferences, communities, and customers. And it occurred to me that a lot of the same Java projects that we were using repetitively were very similarly to a template. So if you've used to templates like Terraform or Bash or PowerShell, then you're familiar with how to template your applications and script them out. So I started templating my applications, and in the morning I would create my application, and then I could spin it up on my mobile phone. Here's me. This is my Samsung A50, and you can see there on the top right-hand side, it actually shows you there's a signal. There's a cell phone signal. And I would start it with my Maven build or my NPN build, and then I would hope that it would work, and I would do the conference and log in whenever I wanted to see exactly my application was up and running. One of the other problems I experience is that don't drop your mobile phone in the shower or the bath while you're using it. Most are waterproof, but they do require you pop them in a bowl of rice and then everything is fine. So today I'm going to show you exactly how we went about doing exactly what I did about reproducing my environment, except using DevContainers and the Azure Dev CLI. Set the stage. Developers are feeling real pain today. They have manually and repetitive mono repos, so large repos that are very hard to work with, and they take hours to begin work. They have slow serial builds with a long inner loop. So what is the long inner loop? What is an inner loop? An inner loop is where you do dev, test, and repeat. And inside your dev cluster, your own laptop or your cloud cluster, and then you're happy with those changes and you push it to a Git repo. We're finding that more and more people are battling to do that because they have underpowered hardware. You're running on a laptop or a desktop, that's not really the same power as your production grade PC. Then also from remote work, most devs are hybrid and they experience latency. You want to be able to move your environment that you do your development on as close to your cloud as possible. Now I live in Johannesburg, so my closest cloud is actually our Johannesburg data centers. But if I wanted to deploy to Western Europe in Ireland, then I would also want to spin up a dev environment close to Ireland. So what is the North Star? A North Star is something that you head towards, which is your direction. And the North Star for dev productivity is a rich local environment, for personalized local environments, for short-lived task environment. When I code, I don't necessarily want to leave my dev environment up indefinitely. I just want to code and test and then tear it down. I also want shared resources and artifacts and run CPU-intensive workloads on the cloud. So if I have something like a build or a GPU or CPU-intensive task, I want to delegate it to the cloud if I want. And then also remote work-friendly. Low latency workloads managed in the cloud and reproducible, meaning that my environment, I can spin up and tear down whenever I want, multiple times. So today we're going to discuss exactly how to do that. We're going to define dev containers. We're going to look at the Azure Developer CLI. Then we're going to do a demo, and then I'm going to give you some links to get started. Let's get started. So what is a dev container? Now recently, we've released a specification, open sourced it, called the Development Containers spec. And you can go to containers.dev, and it allows you to look at how the spec defines that a dev container can utilize features, tools, templates, and collections to actually assist in provide an enriched container with the content and metadata necessary to enable development inside there. And these containers should be, according to our spec, easy to use, create, and recreate. Now, the intention also is to scale these to large development groups and utilize some of the tools to lessen the friction of development environments. So we touched on a little bit about inner loop. So when we look here, you can see that the inner loop incorporates an OS, an operating system, runtimes, and shared libraries. Now the outer loop, the CI, the continuous integration, also needs to run the same OS runtime and shared libraries. So you don't have to worry about, oh, wait a second, it works on my machine, because it's the same as the outer loop. The production container also needs to run the same OS runtimes and shared libraries. So if I'm running Debian in my dev container, it's the same version of Debian Linux that runs in my production. So I don't have to worry about OS conflicts. Then in my inner loop, I also want to share with my outer loop the compiler, SDK, libraries, build tools, and utilities. So I know that my continuous integration and continuous delivery uses the same SDK when they push that artifact to production. In my inner loop then, I also want to have my debugger, my operating system utilities, and my command line utilities. I also want to personalize it and add my own personal productivity tools. All at the same time, it uses the same source control in your inner loop and your outer loop because it's all using Git as the single source of truth. In my production, I've got my compiled application. So my compiled application needs to run on an application server or a runtime, and then I've got my completed environment between my inner loop, outer loop, and my production. So the typical edit loop here, you would add your dev container files to your project. You would edit your dev container files accordingly to what you want. You would open that in a container, and then you would see, wait a second, do I need anything more? If I do, and if there was an error, then I would make changes to the dev container again and carry on, rinse and repeat until I was happy that the dev container was in a good state. Now, when I create my dev container, I can add the dev container configuration files. And as part of that, I can just go into Visual Studio Code and I can say, please add the dev container configuration files. This does need the remote container extension that you can find in the marketplace. And once I get that, it will give me a list of all of the tools and technologies for a specific template. So in this example here, I specified Java. And you can see there that in that Java dropdown, I've got Java Dev Containers, Java 8 Dev Containers, Java and Postgres Dev Container, and then I've got more specialized dev containers like Azure Functions, and the list is quite extensive. And that's the base template. So it gives me a Docker file and a dev container JSON, and we'll go into the specifics of that a little bit later. But that's probably all I need to run. But there's a little bit more, because what if I wanted to run a tool? Now, we've recently changed the way that we drive tools. Instead of you having to execute bash scripts and CLI scripts and a lot of other things, now we call them features. Now, what a feature is, it's basically that bash script or that PowerShell script or that install that we've kind of put into a component that allows you to install those components or multiple components with ease. So in this example here, I've specified CLI, command line interface, and in there you can see the AWS CLI, the Azure CLI, DigitalOcean, .NET CLI, and any CLI that you can think of. And once you add that, it will go in and install the necessary dependencies for those for that feature. So how does this look? So here's my dev container.json. You'll see there in the image, I've got the Docker file. I'm using the Bullseye variant for Debian. And then I've got features. In this example, I've minimized it a little bit. I've only got one feature. You've got the Azure CLI and the version specified. And then for the extension, I've also got just one extension loaded there, which is the Azure Dev extension. I'm opening up some ports because this dev container actually runs on a Docker image. Whether it runs locally on my laptop or it runs in the cloud on code spaces, I still need to open up a port because as Docker images are secure, I still need to open up a port so I can do my dev test and rinse and repeat. And then from the config I have post create command, remote user, which is the Docker user that it's going to run locally. And then the host requirement I specified, please make sure whatever this runs on, the minimum requirement is 8 gigs of RAM. The Docker instance there, you can see it's quite clean. And with those features, all I have to do is actually just install the Azure Developer CLI because we haven't actually released a feature yet for Azure Dev CLI. But every other feature that we're going to do in the demo, the Azure CLI Java is installed with a feature. If you wanted to do all of this manually by hand, you can, and you can go edit the dev container. There's an easier way also to do this. So on the GitHub editor, on your repo, you can drop down under the code spaces window, and you can specify configure dev container. When you do that, it will open up the dev container.json editor, and in there you see now we've included a marketplace. The marketplace has all of the features that we specified with the ability to actually just drag and drop it into your dev container.json. So I'll have an idea and I want to take my idea to production. I want to think of an app and its components and deploy it. So I want to build a to-do application, a task application, and I need a front end, back end, and a database. The back end will help me with my API, and the front end will be my user interface. I want to be able to use React to create the UI, and Java for the backend, and MongoDB for my database. And I'm going to use VS Code as my editor. And also, I want all of this to be available via a dev container that I can either use on my laptop or alternatively in GitHub code spaces. At the same time, I want all of this to be able to be deployed to the cloud with a lot of ease. It is a lot of information, this code to cloud journey. I need to ask myself, which cloud services should I use to use this code? What libraries do I need to reference? What should I set up my local dev environment and how? I need to provision my infrastructure and services. I need to configure my infrastructure and services, my roles and permissions. I hate roles and permissions setting up. It's so much work. My infrastructure as code. I want to run it locally and test it. Then I want to deploy to the cloud. Then I want to set up monitoring and observability. And then also a continuous integration, continuous delivery pipeline. But my goal is just to have an app running in the cloud with CI/CD and monitoring. So there's a lot to take in and a lot to consider. So this is the bicep diagram using the bicep visualizer, you can see there I've got my Azure Container Registry. I've got my container app that has my web app, React.js, that also runs a Java API. It's all secure with Key Vault. And then for storage, I've got the Azure Cosmos DB for MongoDB. And then I use Azure Monitor for monitoring observability. Now, when I look at that with the bicep visualizer, you can see that this view shows me that there's a lot to set up. And there's a lot, every time you see an arrow there's a lot of configuration between the different services. What I want is an easier journey. Now with the Azure Dev CLI, once you have it installed, all you have to do is go AZD app. Now you can specify a template or you can specify the list of templates. And then to set up your GitHub CI/CD pipeline, it's AZD pipeline config, and then AZD monitor to start your Azure Monitor with your observability. It's much simpler than having to manage all of that infrastructure by yourself. So that AZD app actually does a lot under the hood. Let's look at what it does. First of all, it sets up your inner loop to code, test, and debug with a dev cluster. So that's the dev container. It sets up your dev container for you to run where you want to, and it enables you via the dev container to be able to push to GitHub once you've made those changes. Remember, everything runs in GitHub, so it's a single source of truth. Once you're happy with those changes, you can execute a build, or either automated or on schedule, and that build then will go in and create your container image. Remember, we're using Azure Container Apps, so it's going to create a container image, because in truth, it actually runs on Kubernetes, but it makes the development experience much easier than running on Kubernetes. You are then going to use Playwright to do your end-to-end testing. Playwright is a new tool that Microsoft has released similar to Selenium, and then you're going to use GitHub Actions to deploy your code into either your staging environments. You're going to do traffic shaping into your container app or your production environments. Then you're going to use GitHub CodeQL to scan for policies for compliance and governance, make sure that there's no critical vulnerabilities. Use monitoring on Azure Monitor, and then your feedback loop. Once you worked out that there's debugging on an environment, maybe staging environment, and you push a PR, your testing team or your project team pushes a PR, then you can go back to your inner loop and carry on with your dev container with the code, test, and debug with your dev cluster. Now, your dev cluster also has a database, which is important to understand because the Azure Dev CLI sets up your own dev cluster to be self-contained. It has everything you need to do, including your dev environment, to run end-to-end with your code, test, and debug. So I've recorded a little bit of a demo here for us. It's sped up a little bit. It does take a few minutes normally if I didn't speed it up. And this also assumes that I've got Azure Dev CLI already installed. And what you'll notice here is that, let me start the video here. The first thing I'm going to do is I'm going to go AZD app, and I'm going to specify the template that I want. And in this here, I can either specify an empty template or one of the pre-created templates. So you can see there's to-do, C#, Java, Node.js, and then I'll also give you a link for 40 more templates you can access on the repository site. So now it's going to go AZD app. I'm going to specify the environment name to do Mongo ACA, where it's going to be East US 2 on Azure, and now it's going to go create my resources. And you can see here my resources have been created pretty quickly, but it creates a resource group, login analytics workspace, a key vault, application insights, the portal dashboard, the container apps environment, the container apps for my API, for my web, and then the Azure Cosmos DB. Now it's going to deploy the applications. You can see that it's deploying the service API. It's going to build the container, and then it's going to deploy the Key Vault, application insights, and then the container app. And then finally, it's going to deploy the service API, and then the web. So now I can actually go into my Azure portal instance, and I can see that everything has been deployed. I've got my container apps, my API, and my web. I've got my container apps environment, my Cosmos DB instance, my container registry, and my Key Vault log analytics and shared dashboard. I want to test my app to make sure that it is working. So I can go into the API, the Java accessing the database app, and I can execute here and see that it is saying I have 2 tasks, buy milk and wash car. I then can go into the web interface and see that I have a full to-do application there that also says buy milk and wash car. So the next thing I want to do is I want to do some dev test and rinse and repeat and push to Git. So I'm going to open up the dev container. So I'll go into my project and open it up in Visual Studio Code. Now in this dev container, you can see there I've got multiple features and also I've got a few more extensions. I've also got the memory requirement of 8 gigs. It's running on my laptop, so I do need to have 8 gigabytes free in my Docker instance. Now, Visual Studio Code is clever because it actually picks up this is a devcontainer.json file. So I can go into the bottom left-hand side, and you can see there, I can now go reopen in container. If my container is already open, it will open up that instance. So let's click on reopen a container, and it will go see if it can find the Docker instance there. And it did. Not only did it find that dev container running on my laptop, but you can see there that it actually starts off where I left off last. You can set it to timeout and shut down the dev container, or like I like to do is I leave it on for a few minutes in case I want to come back and use it at another time. So in this example here, I've already got my dev container cluster started. So I go into my tasks and I click on debug API, and you can see there I've got my call stack already running. It started up my instance and it's connected to my MongoDB database. And how it does that is it uses an environment file that was created when you actually did the AZD app. So in the AZD app, it's got under the Azure folder, there's an environment file. You can see there under to do Java Mongo ACA and .env file. And that has your Key Vault secret and your hash for connecting to your other resources. So this takes that file, that env file, and in your tasks.json, if I go into my VS Code settings here, and I've got launch.json, you can see there, I actually pass it in to my debug API, that environment file. So I've got my dev cluster, and I'm connecting to the actual database that it deployed to. And then all I have to do is go into my ports here and find the running port here, and I should be able to just go in and open that in browser, and that will bring me to my API example here of my Swagger setup. So I can actually do my dev cluster testing exactly as I would with my staging environment. So I can try it out here, and it will bring me back. It's connecting to the exact same environment that we just did. Should say buy milk and also wash car. Okay, so that is Rory's list. Now I'll take that and go in and find the individual items, and I want to go get that list item there. I want to try it out, and I'm going to specify that list item. And there we have it, buy milk and wash car. So my dev cluster testing is complete. The next thing I want to do here is go in and stop my container or modify my container accordingly. So I've got my environment running, so I can go into here, into my dev cluster. There we are. Now I can stop that. And if I wanted to make changes, or if I wanted to shut down my container, I can go into the remote extension here, and you can see that there's quite a lot of settings here, but I can rebuild that container, or I can actually go in and shut it down in my Docker instance or via my Codespaces instance. Next, my favorite part, let's look at debugging. Now, I've specified a breakpoint into one of the methods there. So when I get my list, so we've already got the list unique identifier, it should break, and we can look at how you can debug. So I'm going to execute here, and it's going to open up the Visual Studio Code instance there, broken on that point there, And you can see there, now I've got full access to the full dev, test, debug capabilities that I want out of my dev cluster. And I can step over, step into, and step out of, and get access to my watch, my variables, my call stack, and also add more breakpoints. Now, all the time, understand that this is actually testing my dev cluster. My to-do repository is actually connecting to my Cosmos DB database. I can go into the to-do repository here, and I can specify and look at the details here around how it's connecting to my Cosmos DB database. I can stop the debugging. I can also use hotcode replace. So let's carry on and see if it returns our items that we want. We want to see buy milk and also wash car, and click continue and resume. If we go back there, you'll see there that I've got that, and then I can execute that again, and it'll pause there, and you can rinse and repeat from that. Finally, let's review what we've discussed over the Azure Developer environment. So when you start out, you'll get your Visual Studio Code instance here, and you can open it again in your container. Now, this is a Docker instance or a CodeSpace instance, so you can actually start debugging and also starting your dev cluster experience. Now, when you're finished with all of that, you'll want to actually clean up your environment. So the easiest way to do that is to first stop your dev container. Then, if you want to delete your resources, you would want to use the Azure Dev CLI to go in and destroy them. So let's stop. Let's close the remote connection. Now this is the local instance here. So let's go and make sure that we've got our local instance. So this is the project, but it's outside the dev container. You can see there it doesn't show that it's running the dev container. It does have all the environment settings. So then you'll just go AZD down. Now the minute you do that, it knows all of the resources that you'll want to destroy. So you can just hit enter, and it'll prompt you to say, would you like to remove all of your instances, including the Key Vault, the Azure Container instances, and the database. It's very similar to going into your resource group on Azure and clicking delete all. The only difference here is that it understands all your resources, where they are, the life cycle of those resources, and it's a much clean, easier way than for you to go in and having to manage the destruction of all of your resources. You can see there, it's fetching the resources, it's making sure that it is aware of all of the different resources, and it also enables you to purge your key vaults, so you don't have to worry about key vaults or manually purging them. It says, this will delete 10 resources. Are you sure you want to continue? And then I just click yes, and it'll take a few minutes, and it'll go delete the resource group with all of the underlying resources. Finally, I want to show you how you can get started with your own template, and I want to introduce you to the awesome Dev CLI portal. So let's go find it here, and this is what it is. It's azure.github.io awesome-azd, and it allows you to go in and specify and look for any template that you want for the Azure Dev CLI. So let's go find this template that I just did. So I've specified Java, container apps, and there's my template there to do application Java Mongo App Service ACA. But I can also do one with Node and also with just App Service. Now, what about other languages here? So I can take all of those specifics, and I can choose and or. So I want to go or. So I want a tool that runs C# and also could run Azure SQL. Now I've got all of these new templates. I've got PyCon Workshop, Django and Azure. I've got Rock Paper Orleans, Distributed.NET, C#, Azure App Service here. And then, wow, look, there's that to-do application and with React and Cosmos DB. You can also go into each one of these. So let's go into the React C# with Cosmos DB, and it'll give you the opportunity to fork the repo and the instructions on how to use the repo. So over here, you can see it's a very similar to-do application, and I can quick start it here. So if I wanted to use the application straight from the Azure Dev CLI, I can, or I can even fork this repo, and in the repo's root, I can just go AZD up. It'll pick up that it is an Azure Dev CLI project and start building it and deploy it to your instance. So this is how you get started. And if you look at this application here, it has a dev container already. And the difference between this dev container, obviously this is a C# one. Look at that. It actually is going to do Node and .NET. So everything that you need to get started is available from that. And I hope this has been an incredible insight to my life as a Azure Cloud Advocate on how I get started in the bath via my phone. I just spin up the Azure Dev CLI, get my environments there, do some coding, and then spin it down whenever I want to remove my resources, and also use the Azure awesome Azure Dev CLI portal to go look for new portals and contribute to the Microsoft templates that are already there. Thank you so much today, and I look forward to seeing you on Twitter. You can follow me on @RoryPreddy, and also reach out to me if you have any queries. Goodbye.